The most dangerous part of a mission to the moon is not the launch. It is the return. By the time Artemis II comes back to Earth, the crew will have already done the thing that sounds impossible. 4 people will have left low Earth orbit, flown around the moon, and turned for home inside Orion, the spacecraft NASA built for deep space human flight. But none of that guarantees survival, because at the very end, after the distance, after the silence, after every major burn has already gone right, the capsule still has to hit Earth's atmosphere at roughly 23,864 millas per hora and live through it. That is the contradiction at the center of this mission. Space looks empty, cold, almost motionless. Reentry is the opposite. It is violent, compressed, irreversible. Orion does not glide home. It arrives carrying an enormous debt of speed, and the atmosphere collects every bit of it at once. The heat shield is expected to face temperatures near 5,000 degrees Fahrenheit. Communications can disappear behind ionized gas. For a few crucial minutes, the spacecraft has to survive largely on the strength of decisions made long before the crew ever left the ground. And that is what makes Artemis II different in a way numbers alone cannot capture. This is not an uncrewed test article. It is not a machine that can be written off as data. There are 4 astronauts inside that capsule: Reed Wiseman, Victor Glover, Christina Koch, Jeremy Hansen. Every calculation, every material choice, every simulation, every check in mission control is ultimately protecting human bodies from a process that does not care about courage, experience, or reputation. A mission can look flawless in deep space and still be decided in the final descent. Because the last minutes are where distance becomes physics, physics becomes heat, and engineering stops being impressive and starts being the only thing between a crew and catastrophe. And that is only the beginning. What is happening here is more precise than most people realize. Orion is not simply dropping back to Earth. By the time Artemis II turns home, the spacecraft is riding a free return trajectory, a path shaped by the gravity of the Earth and Moon, so that after looping around the far side, it is naturally pulled back toward Earth without needing a major propulsion rescue on the return leg. That sounds elegant. It is. But it also means the spacecraft comes back carrying exactly the thing that makes reentry so brutal: deep space velocity. NASA's mission profile places the crew on an approximately 10-day flight that stretches more than 230,000 miles from Earth, with the astronauts traveling about 4,600 miles beyond the Moon before beginning that return. So the final phase is not about slowing down with engines like an airplane on approach. It is about arriving at Earth in the only way possible, then forcing that speed into a narrow, survivable path through the atmosphere. Before entry, Orion's crew module separates from the service module, exposing the heat shield. A short burn helps set the proper entry angle. Then comes atmospheric interface around 400 mil pies above Earth, with Orion moving at nearly 25 times the speed of sound. From that point on, the spacecraft is no longer in a gentle return. It is in a controlled collision with the atmosphere. And this is why it matters so much. Almost everything the mission has accomplished up to this point exists to arrive at this moment in the right condition, in the right orientation, on the right line through space. The journey around the Moon proves reach. Re-entry proves control. It proves that a spacecraft can take human beings beyond low Earth orbit and bring them back through the only barrier that really stands between exploration and survival: Earth's atmosphere itself. NASA describes Artemis II as the first crewed flight test of ISS and Orion in deep space. That last phrase matters. Deep space is not truly mastered when you leave it. It is mastered when you return alive. But that is only the surface of the problem. Because the most dangerous part is not the speed alone. It is what that speed does to the air. The hidden system underneath all of this is not just speed. It is controlled violence. People often describe re-entry as friction. That is only part of the picture and not the part that really explains the danger. Orion is moving so fast that the air in front of it cannot get out of the way cleanly. It is crushed, compressed, shocked into extreme temperatures. That is what creates the superheated flow around the capsule. And at peak entry, that environment drives Orion's heat shield toward temperatures of about 5,000 degrees Fahrenheit. NASA designed this return profile specifically so the spacecraft can survive cislunar entry conditions. Because Artemis II is not coming home from low Earth orbit. It is coming home from the Moon. And Orion does not simply plunge straight through that wall of heat. It uses a skip entry. The capsule dips into the upper atmosphere, uses lift generated by its shape to climb back out briefly, then re-enters again for final descent. That sounds subtle. It is not. That maneuver changes the landing range dramatically, allows far more precise splashdown targeting and splits. What would have been one harder event into two lower acceleration events of about 4 Gs each. In other words, the spacecraft is not just surviving the atmosphere. It is flying it very carefully at the edge of what a blunt capsule can do. This is why the geometry matters so much. The capsule's orientation angle and roll profile are not background details. They are the mechanism that decides how much heat arrives, how fast it arrives, and where the vehicle ends up. NASA's own Artemis II's objectives include measuring how varying trajectories affect thermal protection performance, assessing heat shield structure during entry, and gathering data on avcoat seams and other thermal protection details while the spacecraft is still inside that re-entry furnace. That tells you something important. Even with decades of experience, this phase is still treated as a test of the system at its limit. Then there is the blackout. As Orion descends through about 400 mil-feet plasma forms around the capsule and blocks communications for about 6 minutes, mission control cannot talk the crew through it. Telemetry does not stream normally through the fire, one of NASA's explicit order. Artemis II's objectives is to demonstrate the ability to reacquire GPS after this ionization blackout because, for a stretch of the descent, the spacecraft is wrapped in a physical barrier made by its own speed. The system has to keep guiding itself while the outside world goes silent. That would already be difficult enough. But there is another layer, because none of this matters unless the parts designed to die do their job perfectly. This is the point where the danger stops being theoretical. NASA already had to confront that reality after Artemis I. When Orion came back from its uncrewed lunar mission, engineers found unexpected char loss on the heat shield. Their investigation concluded that gases generated inside the avcoat ablative material did not vent the way they were expected to pressure. Built-up cracking occurred and some charred material broke away in several locations. NASA then ran 8 separate post-flight thermal test campaigns and Sciento 21 tests to understand exactly why it happened. That matters for one reason, above all others, on Artemis II. There are people behind that shield, and the shield is only the first gate. Once Orion has burned away enough speed, another fragile chain begins. Earth's atmosphere can slow the capsule from lunar return velocity to a few hundred miles per hour. After that, the parachute system has to finish the job. NASA describes it as a system of once parachutes, more than 30 milhas de Kevlar lines, and about 36,000 square feet of canopy material, all deploying in a precise sequence, over roughly 10 minutes to slow the crew module from about 300 to 325 miles per hour, down to around 20 miles per hour for splashdown. NASA has also called it the only system that must assemble itself in midair. That phrase sounds technical until you realize what it means. At that stage of the mission, fabric cutters, mortars, lines, timing, and airflow are all part of the same life support system. NASA tested those parachutes not just for nominal performance, but for failure scenarios, because that is how this mission has to be understood, not as a single brilliant machine, but as a sequence of systems that each have to work when the previous one has already handed over the problem. Heat shield, guidance, forward bay cover jettison, drogues, main parachutes, touchdown detection, uprighting, Recovery. Artemis II's own flight objectives explicitly include demonstrating those descent sequences and validating post-landing crew recovery through egress. In other words, the mission is not truly safe when Orion reaches the ocean. It is safe when the crew is out. That is the human cost hidden inside all the engineering. By re-entry day, the astronauts are not improvising. They are stowing equipment, locking down the cabin, adjusting their seats, reviewing weather recovery status and the entry timeline. The service module separates. A final burn fine-tunes the trajectory. Orion reaches its maximum return speed just before entry interface. Then, for the crew choice, begins to disappear. There is no breaking out of it. No turning around. No pause button while the plasma forms and the radios go quiet. What remains is procedure trust and a spacecraft doing exactly what it was built to do, while 4 people ride inside it. And once you see that the entire mission looks different, because Artemis II is not just a voyage to the moon and back. It is a demonstration that survival depends on a chain of events, so exact, so narrow, and so unforgiving, that the final minutes may matter more than the entire distance before them. What makes Artemis II bigger than it first appears is that this mission is not really a destination mission. It is a certification mission with a crew inside it. NASA's stated priorities are not just to fly around the moon, but to prove that the full chain works with human beings aboard crew, survival spacecraft systems, hardware performance, emergency operations recovery, and the data needed for the missions that follow. Orion's life support system is being exercised with astronauts inside. Manual piloting is part of the flight. Even the splashdown and extraction are part of the test. Artemis II is not the reward. It is the exam. That makes the scale stranger. For more than 25 years, human spaceflight has mostly lived inside low Earth orbit. Artemis II breaks that habit. NASA described it as the first time since Apollo 17 that humans have departed Earth orbit, and NASA's own visualization team notes that it is the first time in more than 50 years that people have gone beyond Earth's protective magnetic shield, the magnetosphere. At its maximum distance, Orion is expected to reach about 250 y 2,760 millas from Earth, roughly 4,105 millas, farther than Apollo 13, over a total journey of about 695,081 millas. So, this is not just a loop around the moon. It is a return to a region of space where human presence stopped for half a century. And that distance changes the meaning of every system on board. In low Earth orbit, spacecraft live. In a world of constant support, nearby stations, routine communications, architecture, decades of operational rhythm, Orion is different. NASA describes it as the only spacecraft currently capable of crewed deep space flight and high-speed return from the vicinity of the moon. Artemis II exists to find out whether that capability is real, under crewed conditions, not in theory, not in a simulator, but in the actual environment that future lunar missions and Mars planning depend on. That is why the re-entry matters so much. It is not just the final maneuver of one mission. It is part of the proof that human deep space transportation can be trusted at all. And once you see it that way, the mission becomes harsher than it sounds. Artemis II is often presented as a voyage around the moon. But underneath that story is something much less romantic and much more important. A spacecraft carrying 4 people is being asked to leave the protected routines of modern human spaceflight, operate beyond them, and then survive the one phase that compresses all of that ambition into minutes of fire pressure, silence, and descent. The flight around the moon is historic. The return is consequential. Because if Artemis II cannot come home cleanly, then everything promised after it becomes harder, slower, and far less certain. This is where the entire mission stops looking like a journey and starts looking like a verdict. In the end, Artemis II is judged by a sound most people will never hear. Not the engines at launch, not the calls from mission control, not the silence behind the moon. The sound that matters is the one inside Orion when Earth finally takes hold again. the vibration of plasma outside the hull, the drag building through the structure, the pressure of deceleration forcing 4 astronauts deeper into their seats, while the spacecraft turns speed into heat and heat into survival. NASA built this mission to prove that its systems and teams can sustain a crew not just on the way out, but all the way through return to Earth. That is the standard. Not reaching deep space, returning from it. And that is why the re-entry changes the meaning of everything that came before it. A flight around the moon sounds like exploration. Re-entry reveals what it really is, a test of whether modern human spaceflight can leave the protected habits of low Earth orbit and come back intact. Artemis II is the first crewed Artemis mission, the first human flight around the moon in more than 50 years, and part of the foundation NASA says will support later lunar surface missions and ultimately preparation for Mars. That future does not become real when Orion passes the moon. It becomes real only if the capsule survives the last descent. The parachutes deploy in sequence, the airbags right, the spacecraft in the Pacific, and recovery teams bring the crew home alive. So the final image is not glory, it is consequence. A spacecraft falls out of deep space. The heat shield accepts damage so the crew does not. The parachutes build themselves out of fabric and timing. The ocean rises to meet a machine that minutes earlier was crossing the sky at impossible speed. And somewhere inside all that force is the real point of the mission, to prove that human ambition is not measured only by how far it can go, but by whether it can survive the return. NASA's own description is almost understated. The lessons learned on Artemis II will pave the way for humans to return to the lunar surface. That sentence sounds calm. What it means is much heavier. Before humanity can live farther away, 4 people have to come back through fire and make it look controlled, because the moon is impressive. But getting home is the part that decides whether any of this continues.